Hello and welcome to this pvlib Python tutorial. In this video, we will learn how to directly retrieve data from PVGIS using the I/O tools provided by pvlib. As you can see here, pvlib actually has I/O tools for various sources of data. And down here, you will find the PVGIS for example, the TMY data, which we used in previous tutorials, but also the PVGIS for the hourly data we used in the last one. With this call, you can actually address basically the same information that you would otherwise enter in here. So I'm just going to copy over this one to save me a little bit of typing. And I'll go back to the script we used last time. I'm going to make some changes here. I'm going to delete this part, and also the global. I'm going to import pvlib. And I'm going to substitute this part with the API call and make this a little more readable. Recalculate, multiply over. All right, I'm also gonna call this POA data 2020 right away. So if I now comment out this part, should have less errors. Perfect. So first of all, we need to provide basically the same information as we did before. So I'm going to copy over latitude and longitude from the previous examples over here. I'm going to provide start and end. So this is always the year where you want to have your data. So I'm going to start in 2020 and I'm going to end in 2020. So I get the full year basically. Then for the database, as you've seen previously, I used Sarah 2, but you can go over here into the documentation and choose whatever database fits for your location on Earth. And then you can enter it here. We're going to leave components equals true to get the individual components and not the global irradiance. Surface tilt in my case was 45 degrees. And the surface azimuth for PVGIS for south is 0, remember? Because for pvlib, south actually is 180. So take care of that. Then this part we're gonna leave as it is, and the last part I would like to use the newer version of the API 5.2, so I'm gonna change the URL here, and I don't want to save right now, so we should be good to go. Great. Now we see our data up here, but we also see a whole bunch of information down here. That's because we actually retrieve the metadata and the inputs together with our call. So if we separate these out, we can run again, and our POA data only contains this information. Now, if we look at the columns, as you can already see, they're already renamed to the way they should be to use them inside of pvlib, which is quite handy. So we have to do a little less refactoring, but we still need to do some calculations. So I'm gonna uncomment this again. But we're actually gonna go one step further than before. So in last tutorial, we calculated the POA diffuse from sky diffuse and ground diffuse. POA direct, we actually don't have to do that again. So this time we are again gonna do that, but directly save it to POA data. So we copy over sky diffuse and we copy over ground diffuse. And now our POA data contains POA direct and POA diffuse, so we can just add them up to get our POA global, as you may have already guessed. This plus PUA direct. Great. Air temperature and wind speed are already in the data. And then we can also change the index if we like. But we actually don't have to because it's already reformatted here. So we can run this to double check. Everything looks good. So I'm going to uncomment this and I'm going to save the data this time to PUA data 2020 IO to then use it in our model. Run again. Good. If I go back to my PV model, I can just subsidize the CSV file here with IO. And if I run this again, I have my electricity yield from the PV module using the API call from PVGIS. That's it for this video. If you have any remarks on what I showed you so far, feel free to leave a comment below. Also, if you have questions, comment below this video as well. If you like my videos, leave a thumbs up and follow my channel so others can find these videos and learn about PV modeling as well. Stay curious and we'll meet again for another video. Bye.